Hey, welcome back, Algebra 2 students. Today we're looking at 4-15 exponentials review. Excuse me. The first thing it's asking us to do is graph, so we're just going to talk about how we're going to graph. I'm not going to actually graph it. You guys can do that on your assignment. So what we're going to do is anytime we have an exponential, usually what happens is that everything starts happening around 0. So we're going to put that 0 in the middle for our x in our table. And then we're going to do the 2 lower numbers and 2 higher numbers. And what we're going to do is we're just going to substitute the values in for our x. So 1/4 4 to the negative 2. So remember, the negative means to do the square root of, to do the reciprocal of, and then square root. So we have 1/4. The reciprocal of this is 1/4 squared. So 1/4 squared is 16. And then 1/4 of 1/16 is 1/64. We're going to do the same thing for negative 1. So 1/4 times the reciprocal of 4 is 1/4, which is 1/16. And then anything to the 0 power is going to be 1. So 1/4 times 1 is 1/4. And then 1/4 times 4 to the 1. 1/4 times 4, or 1/4 of 4 is 1. And then 1/4 times 4 squared is going to be 1/4 times 16, which is 4. And then we just plot out our points, and then it'll give us our graph. Okay, on to solving. So we need to remember that we can convert between logarithms and exponentials. Excuse me. So let's write this down. So we know that, let's say we have log base 3 of 9 is 2. Okay, we can convert this. Remember, 3 is the base, 9 is the value, and then 2 is the exponent. Right, so if we were to rewrite this in exponential form, we'd have 3 is our base, 2 is our exponent, and that's equal to 9. So these two equations are saying the same thing, just with different operations. All right, so let's go ahead and solve this. Let's clean this up before we start doing the conversion. We're going to add our 4 to both sides. So you have log base 3 of x plus 1 is equal to 1. And then let's convert this into an exponential. So this is our base. 1 is our exponent. So 3 to the 1 is equal to the value x plus 1. So 3 equals x plus 1. We're going to use our algebra to subtract 1 and move it to the other side. So x is going to be equal to 2. Okay, on to the next one, same idea. This time we got to divide by negative 4 first. So that we have log base 2 of 5x is equal to 12. Negative 12 divided by negative 4 is 3. So now at this point we can rewrite this as an exponential. Our base is 2, our exponent is 3, and our value is 5x. So 2 cubed is 8. And then when we divide by 5, x equals 8 fifths. Okay, on to the next one. So notice this one is not a log. It doesn't start as a log. It starts as an exponential. So anytime we try to get to the exponent, what we're going to do is we're going to use a logarithm, or usually we use natural log, but you can also use a logarithm because the properties are the same. So we're going to say ln, and I'm going to put this in parentheses so we know it's our exponent. So we do ln both sides. right? And what that allows us to do, one of our properties of logs is anytime we do a log or an ln, we can take our exponent and we can drop it down in front of our log. So we have negative x plus 4 times ln 4 equals ln 8. And we're going to just solve this algebraically like we do any other algebra that we have to do. So we're going to divide by ln 4 both sides, so that cancels. And then we have negative x plus 4 equals ln 8 divided by ln 4. We actually don't need the parentheses anymore, so I'm going to erase those because there's nothing outside acting on it, no multiplications or divisions or anything. Okay, we're going to subtract 4. So what we have at this point is negative x equals ln 8 over ln 4 minus 4. And then to get rid of this negative 1, I'm going to multiply by negative x. We're going to multiply by negative 1 both sides. And really, if you can remember, we don't have to do the whole multiplication. You can just remember all the signs change. So we have negative ln 8 over ln 4. And then plus 4. And we're going to do that in our calculators. And what we end up with is negative ln 8 divided by ln 4 minus 4 is negative 5.5. Oh, sorry, plus 4. Is 2.5. Okay, the next one deals with compound interest. So remember the formula for compound interest is a times 1 plus r is the rate. Remember the rate needs to be in a decimal form, not in percent. R over n times nt. N is the number of times that we compound per year. A is the starting value. P is the ending value. And then T is the number of years. All right, so it says that we have 8% interest. We need to make sure that we make that a decimal. So we're going to move the decimal place over twice. So that's 0.086 as a decimal. It's semi-annually, meaning twice a year. So we know that our n is 2. Our rate is 0.086. It says 5,000 is invested, so that would be our starting amount. It's also giving us our end amount. Okay, so when we check, we should make sure that we only have one variable left over, which is t, right? So it says how long. So we're looking for t, which is good. So we're going to start plugging these values in here. P is 7945 equals A is 5,000. Then we have 1 plus 0.086 over n is 2. And then we have 2t. All right, so let's start cleaning this up a little bit. So let's do 1 plus 0.86 divided by 2. So this is 1.043. Now let's start applying some algebra. So we can divide by 5,000 to get that out of there because we're trying to get to our t, right? So let's get that 5,000 out of there. So 7945 divided by 5,000 is 1.589. Okay, so because we want to get to this variable in our exponent, we're going to ln both sides. So ln 1.587. We said the whole reason we want to ln is because we can take our exponent and put it in front of our ln. So 2t ln of 1.043. And then we just want to get our t, and this is all multiplication, so let's do this all in one step. So we're going to divide by the 2 and the ln 1.043. These cancel, the 2's cancel, and then we should have our time. So let's do that in our calculator. ln 1.587 divided by 2 ln 1.043 is 5. We'll say 5. So 5.5 years, which is pretty good, right? You put in $5,000 in 5.5 years, you make almost $3,000 profit or in interest. Okay, and I think this is the last one. Yeah, so this one is compounded continuously, and that's something maybe we haven't talked about before, but we have a different form for continuously compounded interest. So for our continuously compound interest, we are going to go ahead and use the formula, and it involves E. Let's just make sure I'm using the right form here. So we're going to say A is equal to PE to the RT. Okay, so the things are the same thing. So on this left-hand side, this is the end amount. P is the start amount. E is just the constant E. R is our rate, again as a decimal, and then T is the time in years. Okay, so we know we have our 9%. We're going to convert that into a decimal. So our R is 0.09. Our initial investment, right, is going to be our start. That's P11 or 1,100. Our time is 3 years. And we have enough because it's asking us how much do we have after 3 years. So we're trying to find RA. Okay, so A is equal to 1,100. E to the R is 0.09 times 3 years. And we're going to use our calculators. 1100 E to the 0.09 times 3, and we get $1,440.96. Okay, so not too bad. Anytime we see continuously, we're going to switch out. This is pretty much the same equation, except for instead of using the 1 plus R divided by N inside of our parentheses, we're just going to put that whole thing with an E, and it's pretty much the same equation, and we substitute our values in there. In fact, it's probably even easier to calculate because we don't have to do that parentheses part like we did on the last one. This part in here, that whole thing is just an E. Okay, good job today.